We're going to talk about event-driven programming. Event-driven programming is a fundamental way to structure our code, and to be honest, it's the way most code is written. If you think about the programs we've written so far, they worked fine, but they're pretty simplistic, and they're not the way most programs that consumers use every day really work. Right? The programs that we've written start, they do something, and then they exit. Right? They start, they usually process some input, and they exit. That's not how most of my programs work. I leave my web browser up all day long. I often leave my word processor up all day long. Right? Here's my web browser. It's sitting there with google.com loaded. It's not using the CPU. It's just sitting there quietly. Right? My computer's fan is not running. In fact, it really is hardly doing anything until I press a key. At that point, it executed some code. In this case, right, Google did something. I type in another key, it did something more. In fact, it did a lot, right? It took that key, it sent it up to their server and got a prediction. Press another key, it does something else. I press another key, in this case it was a bigger task and it actually fetched a web results and displayed it. The point is, this program was not running all the time in the sense that, well, it was running, but it was running by being quiet, by sleeping. Most of the time, most programs sleep. And instead, they wait for some kind of input. And when that input happens, they quickly wake up and they respond to that input. They do something. It often is a task that doesn't take very long, and then they go back to sleep. The kinds of input that they respond to fall into three categories. They respond to user input, like keys or maybe moving a mouse. They respond to communications input. Right? Maybe an email has come in and your network has woken your program up and said you need to display something new. And there are also timers. Timers are kind of a background mechanism for the computer to notify your program maybe once a minute that it's time for it to wake up and do something. If you want to implement a clock, that will be a nice thing to do. So I want to dive into a little bit how these event-driven programs are structured in the system and how we write our code to implement those. So let's start by looking at how our programs to date have worked. The program starts, control flow passes into the body of the program, and it does some stuff. It might have some loops and iteration and algorithms and processing, and then it exits. And that's what our program does. Now let's look at an event-driven program. We know conceptually that the program must do some initialization to display some stuff. So when the program starts, it does some initialization function. We'll talk about what that does in just a second. And then it basically goes to sleep. And it goes to sleep by notifying the system that it is ready for input. And it does that by calling the system's or the operating system's main loop program, or main loop function. So we're going to have an operating system's main loop. The main loop is going to essentially go to sleep, but it's going to listen to events. And so it's going to sleep. Then it will wake on events, and it will see if there is any programs that need to be notified for that event. And if so, it calls them. And that is that one extra piece that we need to talk about, which is in the initialization part of our program, we need to tell the system what programs or what functions to call when it receives an event. Those functions are called callbacks because the main loop is going to call back to the function that we've registered. So here is our callback. Maybe we just have one, but we could have multiple callbacks. And these really are just a function or a method in our program. But what we're going to do in our initialization is we're going to register the callbacks. And the way we do that is by taking a reference to this callback. Callback functions and method sits in memory just like a variable does. So we can get the address of this callback and pass it to the main loop.
So we're going to register those callbacks first, then we call the main loop. Now the main loop will sleep, wake on events. When it gets an event, it will call the registered callbacks. And then it will go back to the beginning. It's a main loop or an event loop, because all it does is it sleep, wakes on events, callbacks, and goes back to sleep, and it does that over and over again. And as long as there are no events, it stays asleep and doesn't burn up the CPU. It doesn't use any power, or at least not very much. It has one extra function. It has to listen to a special mechanism to exit the main loop. So if it's a graphical user interface, then it might have some X button or some way to close the window, at which point it will actually exit. So what we've got here in an event-driven program is an initialization that registers callbacks, a main loop or an event loop that is mostly sleeping, but when it receives an event, it calls the callback, and then eventually the main loop can exit, at which point your program exits.
So even though the operating system and the graphical user interface platforms provide a main event loop for us, I'm going to write a simple version of one ourselves so we can get a clearer idea of exactly what's going on. So we are going to implement our own main loop in a class called system. And all it needs to do really is keep a list of callbacks so that we can call them back and then have a mechanism to go to sleep, wait for input, and call the callback. So let's start, as always, by defining our constructor. And we are going to create an instance variable called callbacks, which is simply going to be a list. Now, this is going to have to be a list of pointers to methods. That sounds a little bit tricky, but it turns out that's very, very easy in Python. It's just a list, and it will store references just like lists can store references to strings. Let's add a very simple add callback method, and we will take the callback and add it to the list. This is all old hat by now, right? The interesting part is the main loop. So what's that going to look like? Well, what we need to do is essentially just loop forever unless we decide to exit, and we'll figure out how to do that in a minute. So what we need to do is have a way of going to sleep and waking up when we get input. Well, we have a simple way to do that in Python with a built-in function called raw input, which just reads text input from the console. And until the user does something and enters some text, the system just sleeps. So we're going to give the user a little notification that we're waiting for input. If you add a comma, by the way, to the end of a print statement, it won't put a new line in, so we'll actually stay on the same line. So we can have the input on the same line as that string input. And now we can get that input with this special function called raw input. Very simple, that's all it does. And now what we can do is this will go to sleep until somebody types in some text and presses the return key. Now, essentially, we've gotten our event, we've woken up, and so now we want to call the callbacks. So we can have a list of callbacks. We'll iterate over all of them for callback in our instance variable self.callbacks. And it turns out all we have to do is just call callback like that. The variable is a reference, and we can just call that method just like that. And we'll pass in as a parameter whatever the user typed in. That pretty much does it. We do have this one extra feature which we want, which is the ability for the program to quit. And so we can do that by just saying if the input equals a special string, maybe quit, then we want to break out of that while loop. And at this point you've seen the break function, which will stop any containing while or for loop. So that'll break out of there. And that is our whole operating system's main loop. That was probably easier than you thought. Now let's write a simple tester that will use this. So we'll make a new class called tester. I guess I forgot this parentheses up here too. Again, as always, we need to define a constructor. And we need one of those systems, so let's make a system and store it as an instance variable. And let's make a callback. We want to pass in a reference to a method of tester. So actually first let's go ahead and define our callback. So we'll just call a method. Maybe I'll just call it, we'll call it tester callback. There we go. That's nice and simple. It's going to take one parameter, which is the input that the user typed in, and we can do something very simple, which is to just print the fact that we're in a callback and what that input was. Okay, that should do it. And now that we've got this callback, let's go back to our constructor and add the callback to the system. So we'll call that add callback method and pass in a reference to our own tester callback. Now the key thing is we do not want those parentheses. If we had these parentheses here, it would call that method. We don't want to call the method. We want to pass in the address of that method or a reference to that method, and we can do that like this by simply putting in the method name without parentheses. And I think that's about it. Let's go ahead and run this thing. So we'll make a tester, an instance of tester, and I guess we need to start this thing up, and we can do that by calling the main loop. Tester.system main loop. Let's try this out and see what happens. Make sure, by the way, when you press this that you have to click down in the window that has the input, or the text keys won't go there. Alright, I'm going to type in a word, hello. And look at that, our callback got executed and it printed hello. Hi. Hi. It's not doing very much, but it clearly is working the way it's supposed to. Alright, that's about enough. Okay, that's boring. Let's type in our magic word, quit, and the process ends because our main loop, notice we typed in quit and broke out of the main loop. That's equivalent to closing the window and shutting down a program. So even though this didn't do anything much different than we could have done previously with the while loop and raw input, look at our main program. Right? There was no while loop, there was no input. What we did is we defined a callback method that says what should happen when input occurs. And then we initialized the system and registered that callback. And so this is the only code we really had to write. The equivalent of this system exists in the operating system and in the platforms and various renderers and graphical user interface systems that you might use. It actually not only makes our programs easier to write, it makes them much richer because we can work the way real programs work, which is to go to sleep most of the time and respond to user input.